Hey, it's Rick with Welding Training Solutions again. Just want to jump back on here and kind of do a little content here. I'm going to call On the Road with Rick. I do travel all over the United States doing on-site welding training, and so I like to do the content from my shop at my home base, but there's going to be a lot of weeks that I'm not going to be there, and I'd like to post every week here. So anyway, just thought I'd jump on here from my hotel room in Kansas. Just wanted to kind of add a little bit of content from my last installment. We were talking about different base metals and how they react to welding, and so I wanted to kind of get back into that a little bit. So one of the things that I alluded to a little bit is anytime we're welding any kind of material, we have to make sure we're protecting the weld pool, that liquid pool of metal underneath the electric arc. Regardless of process, we have to protect that pool from the atmosphere. And what's in the atmosphere that's a problem is oxygen. 21% of the atmosphere is oxygen, and it's a very reactive gas to a liquid weld pool. And so anytime we're welding, we have to provide that. Different metals require different kinds of protection. If we're stick welding, shielded metal arc welding, the coating on those electrodes, basically as they're consumed in the arc, create a carbon dioxide and carbon monoxide byproduct, and that gas stabilizes the arc, but it also provides immediate protection for the weld pool. The primary protection, however, is from the slag cover. So that coating, as it decomposes, it's less density than the weld pool, and so it flows to the surface, and when it does that, it pulls impurities with it, and then it also covers in the form of a slag, which protects the molten pool, and then of course protects the weld as it cools as well. So in stick welding, that's how that's done. Then we have gas shielded processes: gas metal arc, flux cored arc, gas shielded, gas tungsten arc or TIG welding, and those processes require an externally supplied shielding gas. In gas metal arc welding, that's a wide variety of shielding gases that are used, and we will get into this later on as we talk about that process specifically, but typically it's argon and carbon dioxide. Argon is an inert gas, meaning a non-reactive or benign gas, which does not affect the weld pool at all. And then carbon dioxide is a reactive gas, but it's a positive thing, and it creates a little deeper penetration properties and also a chilling effect on the weld pool. And so those gas mixtures could be anywhere from 75% argon, 25% carbon dioxide. It could be 90% argon, 10% carbon dioxide. There could even be a trimix blend in argon, CO2, and even oxygen, which actually has a positive effect in very small quantities, as usually 2 or 3%. And so that's how that's accomplished. Then you have a shielding gas cylinder, a compressed gas cylinder, that feeds that shielding gas through the cable hose and through a nozzle, and basically protects the weld. Gas tungsten arc welding or TIG welding typically uses pure argon, totally inert shielding gas, sometimes argon and helium, which is also inert, partially because of the material that's going to be welded, which is typically stainless or aluminum or other exotic metals, but also because the tungsten electrode in TIG welding is very reactive to anything that's not inert. And so the shielding gas has to be totally inert in that case. So that's just a couple of examples of different methods in which that liquid pool of metal is protected during the welding process. So anyway, just a little additional content from the last one, and I'm going to try to be on here every week, and sometimes it'll be on the road with Rick, and other times it'll be from my shop at my home base. So anyway, I hope that's helpful. Please continue to listen. Click the bell on my page, and that will make sure you receive content every time I post. So anyway, appreciate your time. Hope it's helpful. Now remember, focus on the fundamentals.